So I handed these out, and just a reminder, you're not the score that's on top of your sheet is not what shows up in the grade book. You should have already seen it show up in the grade book. The grade book score that you received was complete for doing that. But I wanted to give you a score so you could get a feel for how well you did. And if you've never had me for a class before, how tightly I tend to grade so that you can kind of plan for exams and what kinds of things I'm looking for. All right, so if you were surprised by something, I'd definitely like to talk about it, make sure that it's clear to you. Excuse me, but it's not going to directly affect your grade. What's your name?
Colin. C-O-L-R-E-N.
So that is this. Excuse me. And I definitely am willing to talk with you about any questions that you have. Again, one of the primary purposes of this was to make sure that you feel like you're prepared for the mathematical content of the course. Hopefully you've already seen in the past 2 weeks almost now that the material that we've done for the prerequisite exam reflected the type of work that we're going to be doing in the class. And so if you struggled in that, either you sought help or it's being refreshed for you in the midst of class. Any questions about the prerequisite exam before we move on? All right. So then let's pick up where we left off on Friday. I need an eraser. You will recall that we were talking about problem 236. And we had set up our model, and so I'm going to write it more compactly here so I can do the first graph side by side for this first one. So what we said is that we were going to minimize our cost, which was, I think we didn't put that in there, did we? That was what we had left to do. Would we say that, what is the cost objective for problem 236? Pull out your textbooks and share them as needed. At this point, your textbooks, I'm expecting this is probably the last week that you're probably going to wait for textbooks. A few of you have asked for me help, have asked help for me offline or online, and I've had to say, can you tell me what the problem is again? Because my books are in the lab, so I need to get those back so I can help with those of you who need help. So make sure you're expediting that process of getting the textbook and able to utilize that. Okay, so hopefully that gave you enough time to turn to that page. What is the objective? What is the cost? We already know we're going to minimize the cost. What is the cost for this model right here? Who wants to help me out here? Yeah, you look like...
It's $10,000 per training for Keeney.
Uh-huh.
And then $8,000 for problem solving.
So the cost is going to be $10,000 for each training and $8,000 for each problem-solving class that we offer. Okay? So that's the last bit of information that we hadn't completed. So what does ST stand for again? Subject to the following constraints. T is greater than or equal to 8. P is greater than or equal to 10. T plus P is greater than or equal to 25. and 3t plus 2p is less than or equal to 84. Now, how did we modify these functions again, real quickly? To move them into standard form? Added slack or surplus variables. So first one, is it a slack or is it a surplus variable? How do you know it's surplus? Because it's greater than or equal. So do we add or subtract surplus variables? Subtract. So we're going to do minus S1 right here. How about the next one? Same thing. It's a greater than or equal, right? So we subtract our second surplus variable. Our third one? Same thing. And our fourth one is now a slack variable, right? Because we have a less than or equal to. So we're going to add that. Okay. What have I left off of this equation? Our logical constraints. So let's put those in. T and P. And now we're going to add our surplus and slack variables here. So S1, S2, S3, and S4. Okay? And one thing I didn't mention, because it's maybe seemingly obvious, is that adding the surplus or the slack variables does not change the overall cost or our objective function. A lot of people want to explicitly put that in there by doing this. Right, so having slack or having surplus does not benefit or does not hurt us in any way. Our cost function is unchanged here. Okay? So let's go ahead and solve this. To this point, what do we use to solve these equations? We're going to use a graph, right? Oh, no. Is our yardstick missing? Oh, is it in the corner? No? Darn. Oh, Ross.
Ross stole it. Ross stole it. You felt bad.
Thank you, Ross. All right. So let's draw this out here. And again, I'm freehanding this, so this isn't going to be perfect. I would definitely recommend graph paper. And let's, because I get something in my throat here. Because these are small numbers, let's do units of tens. All right? So let's do this first graph here. Okay? And I know this might have been confusing to a few of the people working on the homework over the weekend. How do we graph that now that we've got a new variable? This is in terms of, well, let's give it a x and y axis. So what should we do on the x axis? T and P. So notice we don't have any place for our slack or surplus variable, so we're not going to initially show them in our graph. We'll just treat it the same as we did before. T is greater than or equal to 8. Right? So how do we do that? Is that what kind of line is that? Vertical line. Add up at 8 here, right? And what direction was the greater than equal going to refer to? Where was the feasible region going to be? To the right here. All right? So I'm oftentimes going to mark this way, so it's just really easy for me to remember which line is which. Okay, so we'll do our next line here. P is greater than or equal to 10. What kind of line is that? Horizontal at 10, right? And what direction are we going from there? We're going up, right? Okay. Let's see if the that's not very visible, is it? Let's see if my backup red works here. There we go. All right. So T plus P equals is greater than or equal to 25. So if P is 0, T is going to be 25. So 10, 25 right here. And the same is true, right? If T is 0, then P is going to be 25. And we can just connect that right there. And what direction are we going there? Where's the feasible region? It's above it, right? And I'm out of colors because my green marker isn't working so hot. So I'll just use a dashed line here. Okay. 3t plus 2p is 84. So what happens if p is 0? What is t going to be? 84 thirds, which is it's 28. So that's right here. And if t is 0, p is going to be 42. So 10, 20, 30, 42 right here. So we've got a smaller region here, but we can do that. Okay. What direction do we go from there? To the left, right? Because this is less than. So our feasible region is right in here. And if we're minimizing now, in general, we're going to be going not away from the origin, but typically we're going to be going towards the origin, right? Because those are going to be smaller and smaller ones. So let's, again, take our objective function and assign it some arbitrary value. Okay? Excuse me. So let's give it, let's say $300,000. Okay? So let's temporarily assign it $300,000. Say it costs us that much. Okay? So what is the value of t going to be? 300,000 divided by 10,000? 30. That's off the chart. Let's make this 100,000. Okay? So now it's 100,000 divided by 10,000 gives us 10, right? And that's for t, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
We were going by 10.
Oh, so I should have done 300,000. Thank you. So that makes that 30. 10, 20, 30.
Close one.
And what is 300,000 divided by p? 38ths, right? So that would be 3. 300/8 is 3. 7, right? 37 and a half?
Yeah.
10, 20, 37 and a half. So I'm going to do this in a different dotted blue here. Okay? And what's going to happen here, it's always nicer if we have a bigger thing, is this is going to slide through like this, and it's going to go out right here, right? That's going to be the last place that it goes out. Okay? And we could solve for, we know what t is, right? Because it hits this black line. So t is going to be 8. And then we need, it's intersecting with this red line right here, right? So 8 plus something is going to get us 25. P is going to equal 17 right here. Okay? Now notice I was able to use the black line and the red lines to help me solve the problem. That's because the solution was at the intersection of those, right? Those are binding constraints. Okay, that's an important term, a binding constraint. That means it's a constraint that directly affects the solution that we're going to optimize for. Notice that our blue constraint right here, that P had to be greater than or equal to 10, that's not binding. We could have changed this 10. We could have changed it to 15. So we have to have at least 15 problem solving. It wouldn't change our answer. It would have bumped this up, but it still would have been below that 17 mark right here. Okay? And so that could have been completely gone. It still wouldn't have changed the solution. Only the constraints that said we had to have at least 8 teaming problems and that we had to have at least 25 affected our final solution. All right? So those two right here are binding, and we will creatively call these two non-binding. All right? I know it's tough to remember the difference. All right? And this will become important in a little bit. So if this and this are binding, what should their surplus values be? They have to be 0 by definition, because if they weren't 0, then they wouldn't be bound. There would be more available to use. But there isn't any more available. That's what defines them as being binding. So we already know that S1 and S3 are 0. How about S2? What's the value of S2 here? P is what? 17. What do we have to subtract from 17 to get 10? 7. So S2 is 7 right there. This is the blue line right here. This distance right here is S2 on our graph. It's the distance between our solution point and that constraint point. Okay, there's 7 difference between those two. How about S4? What's the value of S4? Let's figure it out. 3 times 8 is 24. 2 times 17 is 34. So that gives us 58. Right? So then we can just do 84 minus 58 gets us 26. So S4 is 26. And again, this is for our dashed line. It's the distance here. All right. All right. So that gives us how much extra we have available to us. All right. So hopefully you were able to do this in your assignment for today. If not, you can revisit them and make sense of it and make sure that you were still doing what you were supposed to do. Another reason for allowing you to do completion grading, right? Did you do what you could, and did you understand? If not, you can go back and do more problems on your own. You know whether or not you're ready for to be done doing some problem statements. All right. Let's so let me just put what I have down. 2.20 was problem due for today, right? That's what you worked on? Let me put down what I believe the answer should have been, because it's very similar to this. And then if you have questions, you know to seek me. All right. So for 220, the answer should be that A equals B equals 24/7. Okay. S2 is equal to S4, and those are 0. Those are the binding constraints, your second and your fourth constraints. S1 is 20/7, and S3 equals 10/7. Okay, so that's what I have for the solution to 220, doing the exact same steps as we did on the board here for 239. Oh, not 236. All right, so make sure you check your work. See if it fits. If not, that's when you talk to someone else, talk to me. Make sure that it makes sense. All right, open your books then to problem 239. We're going to look at another problem here. Right, so go ahead, work on this on your table. Go through the first two steps of the process. What did we say the first two steps of the process are? What's step one? Define your variable. Step two? Define your goal. If you get those two, then go on to step three, start defining your constraints. All right, go ahead as your table.
Number of stock.
Figure out the goal. What's the goal? What's our goal, Mom?
Well, it's just if you had to bring like 50,
All right. Let's start with number one. Let's define our variables. I'll go up the front table right here. What did you say our variables are?
S for the number of units in the stock fund.
Okay, so S equals the number of units. That's important in stock. Because again, some people like to think of it in dollar amounts, but we're trying to figure out how many stocks to buy, not how much money to put into each one.
And the number of units in the money.
All right. Back one, what did you guys say the goal was?
Minimize your risk.
Minimize risk. Okay. This is not always what an investment goal might be, right? Maybe your goal might be to maximize in return on investment, right? So we need to make sure when we get to step 4 and we put this in terms of an equation that we represent the risk properly. Okay? Let's keep going around. Can you give me one of the constraints in this problem in the back there?
50s plus 100m is less or equal to 1.2 million.
Is less than or equal to, you said?
Yeah. 1.2 million.
Okay, and what does that represent in English?
The price, so it's $50 per share
Uh-huh.
that you're buying in the stock fund
Uh-huh.
versus the money market at $100.
Okay, so this equation then represents,
The total amount of money that you're willing to invest.
right, total investment, right? Okay, keep coming around. What's the next constraint that you see in this problem?
Yeah, we had 5F plus 4M greater than or equal to 60,000.
And what does that represent?
It's the return, the annual return.
Okay. Right, we're going to make 5% on stocks, 4%, or actually 10%, because we bought it for 50. 10% on stocks, 4% on money market, and we have to make at least $60,000 off that. All right. Let's go up, come up. Center table, what's another constraint?
M is greater than.
Come on.
Did you say M is greater than equal? Okay, 100M is greater than equal to 300,000. And what does this represent?
The minimum investment in the money market.
Okay. Yes.
So why is it 5S instead of 10S?
Because 10% of 50 is 5. So the difference is 4% of 100 is 4. Right? So we bought them at different prices, and so that's why a 10% return gets us 5 rather than 10. But a 4% here gives us 4 because it's of the purchase price, not of absolute dollars. All right. Now we'll come up here. Constraint.
Logical constraints.
Logical constraints, which are?
S
All right. Help me transform this into standard equation then. Standard form.
Be 50s plus 100m plus S1 is equal to $1.2 million.
Plus S1 is equal to?
Yeah.
Okay. Next one.
Minus S2.
All right. And last one. Minus S3. And then we add in S1, S2, S3. Is everyone good with that? Yes.
Do we need to include M in the logical constraints, even though you already have one explaining that it has to be over 300,000 anyway?
Yes, because we're not always going to have a horizontal line like this. This is duplicative in this case, but we want to make sure, because once we start getting multivariables, it's going to be a lot harder to notice that all our constraints eliminate those logical constraints. So we just want to be explicit about that, even if it isn't going to be graphed and help us in this case. All right. So then we've got 1, 2, 3, 4. Step 4 then is minimize risk. So in the back corner, what's the equation for risk?
8S plus 3M.
Mm-hmm. All right, we said that's on a scale of 1 to 10, it's 8. We take a risk of 8 for each one, but we only take 3 for the money market. All right? So this is part A. All right. This was also a homework assignment for today, right? This one. So part B, I will dispense with the graphing it, because I think you're getting good at being able to graph it and see if we get the right solution. So for part B, the solution was that should buy 4,000 units of the stock fund. You should buy 10,000 units of the mutual fund. All right? Which means your total investment was what? How much are we investing if we do that?
62.
No. We have to multiply 4,000 times 50, right? And that gets us 200,000. Right? You have 3 zeros here. We have another 0 here. And then 5 times 4 gives us 20 for an additional 0. So we spend $200,000 in stock fund. For 10,000 times 100, you get, that's your 10,000 and your 100. Whoops. So you spend 1.2 million. Right? So we're going to spend as much as possible. All right? So the total investment is $1.2 million. And what is the return? The annual return?
60.
That's 60,000. Right? Because We do 4,000 here. So that gets us 20,000 plus 10,000 here. Wait. 4,000 here gives us 20,000 plus 10,000 here gives us 40,000. 20 plus 40 gives us our $60,000. Okay? So that's part B. What is part C asking for? How do we change up the problem here in part C?
You want to maximize return instead of minimizing risk.
So how does that change it? Instead of this being our objective, now what is our objective?
5S plus 4M.
It's this, right? So we want to maximize 5S plus 4M. You already know this line because you've graphed it. So you know where it's going to exit. So again, you're going to invest. Let me do it in the same order here. Now you're going to buy 18,000 units of stock and only 3,000 units of your money market. Which should make sense if you think about it, right? Because we're going to make a lot more off of every stock unit that we buy than the money market. So if we're trying to maximize that, we want to buy as much possible stock as we can. What's going to be the binding constraint in that? It's this minimum that we have to buy at least $300,000 in our money market. So if we do 300,000 divided by 100, that's where we get 3,000 units. And then everything else is going to be in stock. And again, we're going to want to invest it all, right? Because we're getting a positive return. So the more we can invest, the more we're going to get back. So we spend up to our maximum limit of $1.2 million on stock. The remaining is on stock. And our return in this case is $102,000 per year annual return. Okay? Very different behaviors, but it's because we're trying to accomplish two very different things. Right? This might be for someone who's retired and they can't afford to lose all their money, right? That would be disastrous. So it's more important that they make sure that they preserve their capital and maybe make a little bit of money versus someone who's got a lot of time left. So if the market tanks and we do have high risk and we don't get this $102,000 for any given year, we'll still average that over the lifetime of it and we'll be okay because we have a long lifetime ahead of us, right? And so two different objectives may result in two different investment strategies here. All right, again, compare these values to what you put down on your answer sheet and make sure that you understand why they're the way they are. Questions? Okay, so let me introduce, finally, a new topic for Wednesday. We'll explore more deeply. So we'll talk about this conceptually here today, and then we'll talk about it mathematically on Wednesday. And that topic is sensitivity analysis. Okay? And the idea behind sensitivity analysis is that, well, when we're making these mathematical models, we're approximating reality. In fact, sometimes we might even be making some assumptions about how things work or how they behave or what the future is going to hold, what the availability of certain product is, how much it might cost us, how much we might sell something for. Those are assumptions that go deeply into our solution. And the idea of sensitivity analysis is to specifically ask the question, what happens if our assumptions are wrong? How does that affect our final answer? Does it not affect it at all? Think about the binding constraints that we talked about. That's an example of rudimentary sensitivity analysis, where we could change our estimate of how much something's going to cost. If it's not a binding constraint, it doesn't matter. We could have been off by quite a significant amount before that constraint becomes binding, and that constraint affects the total cost, the total overall objective value. And so what we want to be able to do is understand that very well, because what we don't want to do is if we're in the workplace and we're doing this kind of work where we're analyzing these kind of problems and we're presenting a solution for management to make a management decision about what to do next, to give them one value and say, this is it, this is what we should do. There should be some sort of understanding about how the assumptions that you've put into your model, and you can say, well, with high probability, 80% chance we think that this is going to happen. But if we're wrong about this, there's a 20% chance that the alternative should look like this. And it's the process of doing sensitivity analysis that allows us to specifically understand that how much those assumptions affect our final solutions. Maybe we have something that we know is we're sure about, and the model is really sensitive to that. That's not a big deal, because we know that it's not really an assumption. It's really deeply embedded into how things work. But on the other hand, if we're really uncertain, well, I kind of threw a dart at a dartboard and I came up with something like 10,000, but it could be 20,000 or 100,000. I don't know. Well, you should probably not say some answer with high confidence if that value then directly affects the final solution. You should that should be a part of your presentation for the decision makers about why that value can change drastically and how that's going to affect your final solution. So when we're doing sensitivity analysis, what we're going to do is we're going to look for this class at two specific ways that we can be sensitive. The first one is we can look at the coefficients in our objective function. Okay? So for the previous example, that was the risk of those different investment strategies. So what if it's more risky than we thought to buy stock? How is that going to change how we go forward? What if it's less risky to buy stock? Again, how is that going to go forward? And so forth. So that's the coefficients we're going to look at. The other one, I'm going to abbreviate this as RHS, the right-hand side. So we're always doing our equations, variables greater than equal or less than equal some constant value. That's what we're looking at, is that right-hand side constant value. So we're looking at what if we could have more money available to us? What if we have to spend a larger minimum on the money market in the previous example that we just looked at? Those were the right-hand side values in our model. And so then we can ask questions like, what if I'm wrong? What if my cost estimate is off? What if I expected 5 people to show up to work, but someone called in sick, and I have different amount of labor hours than I expected? What happens if there's a snowstorm in the northern states and it slows down shipments to my factories? What if new regulations come into effect or go out of effect? How does that change my modeling of the situation, right? Those are things that we can take into effect here. All right. I'd like to stop there. So if you have any questions, please let me know. I want to work with you and make sure everything is clear. Otherwise, I'll look forward to seeing you on Wednesday's lecture.